So today we have a 2009 GMC Sierra. It was towed in, and the story is they boosted it by mistake with 24 volts. And after that, the vehicle hasn't started or isn't running. It won't crank. Now I can see that they've tried a fuse box under the hood, and so it looks like they've got a used computer in there, which will be a problem with security, I'm sure. I see the original one looks to be on the passenger seat. I did a quick scan on it. Of course, it wouldn't auto ID. There you go, photo bomber. And I got no communication with anything on the high-speed network and on the CAN bus network, but it looks like I have CAN activity here, although that's not conclusive. It just shows it's not completely dead. So I'm going to start by putting the original ECM back in it, and then we'll have a look at how the network is configured on this thing to see what module might be taking down or preventing communication with the PCM or ECM. So as you can see here, we got communication with 10 controllers, the airbag module, and it has a system configuration error, incorrect component installed. That usually happens when somebody puts an unprogrammed or a module with a different VIN number in it, like the PCM. We got communication with the HVAC, we got communication with the instrument panel, and that's showing loss of communication with security control module. We've got communication with keyless entry, passenger presence, radio, theft deterrent, tire pressure monitor, vehicle communication interface, but no ABS, no transmission, no PCM, and I think this should have a trailer brake control module or a fuel pump driver module. No communication with those either. As I said, it shows 10 modules it communicated with. Should be more like 15, 16 on this truck. So let's have a look at the network on this thing. So here's a look at the high-speed CAN bus from pins 6 and 14 of the DLC, and it goes off to a connector on the junction box underneath the left side of the dash. From there it goes to the BCM, out of the BCM to the transmission controller, and out of the transmission controller, come on, scroll down. I don't know why this don't want to scroll down now. Out of the transmission controller, this would be the M30 controller, to the ECM. The ECM has a terminating resistor in it. On the other end of the network is a vehicle communication interface module, transfer case controller, but this is a manual transfer case, ABS controller, and a fuel pump driver module towards the back of the vehicle. So let's start by measuring the terminating resistance at pins 6 and 14 of the DLC. Right over here, 6 and 14 of the DLC. Should be 60 ohms if the network is not open or shorted, because there's a terminating resistor in the back of the truck, which could incidentally be the cause of the problem. But again, having been connected to a higher than normal system voltage, could have done anything to any controller in the system. Could have taken out the BCM, and that's what could be preventing communication here. BCM, because I know I don't have communication with the BCM. Let's try that, because I never communicated with the BCM. And let's see, body control module, display codes, no communication. So everything on the high-speed bus is not communicating. So let's start with measuring that terminating resistance. And then we'll have a look at the CAN bus signal, see what it looks like on a lab scope. So I got the 2-channel lab scope hooked up to pin 6 and 14 and 4 for a ground. And this is what the CAN bus activity looks like. Should be a mirror image, with CAN H being 2.5 volts plus a volt and CAN L being 2.5 volts minus a volt. It's certainly not very clean. I haven't tested terminating resistance. I wanted to look at the pattern, but it's definitely not very clean. That could be a BCM problem. Again, this thing had 24 volts connected to it, so it could have taken out a number of things. But we'll disconnect the battery and check terminating resistance. So here's the schematic again, and I've got the ohm meter connected across 6 and 14, again with the battery disconnected so there's no voltage present. Should read 60 ohms because there's a 120 ohm resistor in the ECM over here, and at the other end of the network, probably on the next page, it'll show the terminating resistor. It's either in the harness or it's in the trailer brake control module. There's a data link resistor there. So the problem could be in this circuit somewhere, but it's definitely not shorted. It's definitely an open circuit. I think we're going to try and see if we can split this in half. Let's go back to this previous diagram. Locate this connector under the dash. This, try and blow that up a little bit. X3 connector under the left junction box IP. Identify this circuit here, 1 and 3, and measure the resistance to the back half and compare it. That would tell me if the problem's in the open, it's in the back, or it's in the front. Now again, an open shouldn't cause a loss of communication, so I'm really skeptical that the BCM hasn't been fried by the high voltage boosting. Let's see. So that X3 connector is at the bottom of the junction block under the left side of the dash, but it's on the bottom behind it, so you have to fold it down. I've got this X3 connector unplugged, and it still reads 122 ohms, which tells me that the open is in the back of the system now. I wonder if by taking that back bunch of computers out of the circuit now, if we have communication. I'm going to reconnect the battery and check the network. So you can see that green connector hanging down there. That's X3, and that has the high-speed CAN bus going in and back out to the rear of the vehicle. Now with that disabled, my network voltage looks normal, and I should have communication now, I would think. So we're going to try the scan tool now, see if we got communication. So I've got the original ECM reinstalled, and I'm going to do a network code clear. Okay, now we've got 12 computers. We've got the ECM and the BCM that we didn't have before. But remember, the back half of the network is still down. Let's see if we got any codes in the ECM. Lost communication with the fuel pump control module. No kidding. Well, just for shits and giggles, we're going to see if this thing will start. Let's go into data and engine data, and I'm going to see if it'll start. I don't believe it will because we have no fuel pump. Well, we had some residual fuel pressure in the rail, so we got to get that fuel pump back online. Ambient air temperature minus 40. That's not right. Intake air. Might have the air induction system disconnected right now. Well, that's a minor detail. At least we know it runs. Let's just check for codes and see if there's an intake air temp sensor code. Just the lost communication. So we're going to have to lift it up and have a look at the terminating resistor in the back. So we're looking at this back half of this network now. I've got this X3 plug unplugged at the bottom of the fuse box or junction block underneath the left side of the dash. So out of there it goes to the OnStar module, which this vehicle does have, vehicle communication interface, and then it goes to the next page here to the transfer case shift control module, but this vehicle is a manual transfer case. And from there it goes to the anti-lock brake, out of the anti-lock brake to the fuel pump driver module, and to the data link resistor. So let's have a look underneath the truck where this stuff is. So there's the ABS module. We could check it from here, because from here it goes to the back. Fortunately the spare tire is not on here, so we can see the fuel pump driver module right here, and this would be the terminating resistor right there. We're going to take that apart and have a look in it and see if there's any corrosion, but there could be a problem in this trailer brake control module, I'm sorry, the fuel pump driver module, or in the wiring anywhere. So we're going to take apart a couple of connections here and see if we can see anything obvious. So there's the fuel pump control module disconnected, and all the wires look pretty good. There's the high-speed CAN bus wires, the tan and black and the tan wires coming in and going out. I took that terminating resistor out and looked at it. It looks good. There's no green corrosion in it. And I disconnected the ABS module connector here, and it looks clean. So we're going to reconnect it. Put some dielectric grease in here and reconnect it, and reconnect that X3 connector under the IP fuse box or junction block, and then check it back here at the trailer brake, sorry, I keep saying trailer brake, at the fuel pump control module, and see if we've got network activity back there. So that's network activity at the DLC with the ABS module reconnected. So now I'm going to try and reconnect the fuel pump driver module and see if it goes crazy. As soon as I plug in the fuel pump driver module, the network goes stupid. So I'm going to disconnect it again while it's still running there. I can get this connector up. So with it disconnected, the network activity looks normal now. So we'll get a fuel pump driver module for this thing. So I took the trailer or the fuel pump driver module right out of the circuit now, and I'm going to see if I got communication with the ABS. It's under 8600 UW. I'm not sure if it's without vehicle speed, vehicle stability enhancement. I'm sure it doesn't have that. Let's see if we have any codes in there. Current codes: ECU performance, pump motor malfunction, right front wheel speed, base brake system pressure booster. Lots of codes. Interesting, those codes don't erase by simply taking the power away. Let's clear the codes out of the system. Give it a sec. Let's have a look at data. ABS failed, yes. Interesting. Well, let's see what codes came back. There could be a problem with this ABS unit too as well, but that's not the cause of the network issue. ECU performance current history DTC since power up requested. Well, that's a secondary issue. So I took that thing off. I had to break it off because the little bolts that hold it on, there's no way they're coming out. So I cut this one with a zip cut blade, then just pried it off and then cut the brackets off. I took the cover off of it. It's glued together. It's not meant to come apart. I don't see anything obviously wrong in here, but we're going to get a fuel pump driver module, and it has to be flashed to the vehicle, which I can do, and put it back together again and see if it runs. So just temporarily what I'm going to do is put power to the fuel pump at the fuel pump module connector. 47 is power, 16 is ground, 1 is ground, and 32 is the main feed power coming in from this 20 amp fuse. So looking at the actual connector view, here it is here. We need to connect 32 to 47 and 1 to 16. So the two large terminals directly along from each other. So I'll show you how I've done that. So this is the power wire coming in. You can see the heavy red wire, and I've got a fuse jumper wire installed from there to there, and if I connect 16 to 1, you can hear the fuel pump in the tank runs. So that'll allow me to get it out of the shop at least. So as you can see, it runs like that. I just want to get it out of the shop so I don't have to push it in, pull it out. We're going to put everything back together again. I put a switch on that ground wire on that fuel pump so I can turn it off. So the reason why the ambient air temperature was showing -40 is because the mass airflow sensor was unplugged. And I see they've removed the maxi fuse, or they must have blew the fuse by the battery there, and they moved the studs over to the same stud, so there's no fuse in there. I'll have to replace that. This is the wrong battery in the vehicle, and there's no battery hold down. The positive cable should be towards the front of the vehicle. The way it is now, that battery could slide back and actually short against that firewall right here. It's pretty close. Well, we'll talk to him about that. We got to get a maxi fuse and a fuel pump driver module. So there's the new fuel pump driver module from GM. Check your part number. Now it doesn't come with the retaining bolts. The bolts are actually threaded from the top down, but the original bolts had an E Torx bit on the end of them. So I've taken some 6mm bolts and just cut a slot in them. Should be able to turn them down with a standard screwdriver to install it. Because you can't get your hand up on top of that bracket. And I had to cut the old bolts off, as you remember. So we're going to install this, and then we're going to go ahead and program. So there's a new module installed. You can't actually get at these bolts from the top, but it's easier. The original bolts had little Torx head ends on them, so you could screw them down from the bottom, but they're good and tight. Make sure you blow any sand out of this connector because you don't want it binding on the way in. It'll break these plastic ears off, these little tabs off of here. And we're going to put some dielectric grease on the terminals and reconnect it and then go through the programming procedure. So I've logged into my AC Delco SPS programming website. I've already purchased a new license, so we're going to add a VIN. I'm using the Veris Edge and the GM MDS2 pass-through, and they always tell you the service news. Click on service programming, start service programming. It's going to download a little JavaScript. Click on that. Because I have to do this every time, it takes more time to actually install the software than it does to actually do the service programming of the module that's been installed. I've got a battery charger, a clean battery charger connected to the battery. I got the key on right now. And it's going to take several minutes to install this software, so I'll pick up as it goes along here. So it's asking me if I want to run this application. Click on run. And now it looks like nothing's happening, so just be patient because it's actually installing in the background. It takes about 3 or 4 minutes. It appears that the software is locked, but it's not. And it might be because I'm on a slow internet connection. It does say be patient if you have a slow internet connection. So I'm going to pause this recording until the software loads. So the software is loaded. Now my furnace and compressor are both running. We're going to go replace and reprogram an ECU. Select next. Turn the ignition off. I've already done it. I've already got the part installed, so we should be good to go next. Now, it doesn't automatically extract the VIN number. You have to tell it what you're working on, and you have to tell it what year. And it's a light-duty truck, and it's a Sierra. Now it will communicate with the vehicle computers, provided there's nothing wrong with the network, and it should pull the VIN number up in a second. I don't know when my furnace and compressor both have to start now. Make sure the VIN is displayed. Well, I'll get the VIN number. So I don't know why it didn't pull the VIN. Normally it does, so I've manually entered it. I hope this is not a sign of something wrong with the system still. And we've got to go down here and find the fuel pump driver, fuel pump control module. Normal, next. Remove it, install it, turn the key on, next. Communicating with the device. Okay. So the reason why it won't program is because we still have some nasty looking network activity. And it's not the terminating resistor because I measured that. But if I take the fuel pump driver module out of the network, the communication signal cleans up completely. So there's what the signal looks like. Picture perfect CAN bus waveform with the new fuel pump driver module unplugged. Of course I can't program it if it's unplugged. As soon as I plug it in, the system goes for a shit. So I'm going to check from the fuel pump driver module to the terminating resistor and see if there's a short in those wires. So looking at the schematic, at the fuel pump driver module, flow control module, pins 21 and 22 are CAN bus signals in, and then 6 and 7 go out to the 120 ohm resistor. So looking at this connector, pin 1 I believe, which is the ground, and then 6 and 7 are going to the resistor, and 21, 22. So I've got it disconnected. I want to look at the CAN bus signals on 21 and 22 and see how they look. So this is pin 22, and you can see we have a nice CAN bus signal on it. But pin 21 should have the opposite signal, and we've got that. Damn. So I guess when you plug in the controller, it goes through the controller to the resistor, and the resistor connects the two circuits together through the terminating resistor, and that causes it to pull it down. So there's a wiring issue on the pin that goes to 21. It should look like this, but upside down. So we're going to check it at the ABS module. On the ABS module, and it depends what brake option it has. You can see here it could be coming in and going out. So we're going to check it at the ABS module now, do the same test. So now I got the ohm meter connected to the terminating resistor circuit, pins 6 and 7 at the fuel pump module connector. So it shows 122 ohms because we've only got one resistor in the circuit. So that circuit is not shorted or open. So the question is, what's wrong with pin 21 in that circuit? So at the ABS module, there are 3 different brake options. This one's JL4, and the signals coming in are on pin 36 and 24. 36 is CAN plus and 24 is CAN minus. So that's those 2 pins at the bottom of the connector. So I'm looking at pin 24 right now, and that looks good. Let's have a look at pin 36. So there's CAN 36 is CAN plus, and 24 is CAN minus. You can see this one goes up a volt and the other one goes down a volt. The reason why it doesn't show up there is because the trigger's not set. If I move the trigger down, you'll see it capture it. So the signals are good to pins 36 and 24. Now there could be something going on in this ABS controller that's taking down the bus. I think what I'm going to do is jumper it with 2 jumper wires to continue the bus signal to the back, and then basically take the ABS controller out of the network and check it at the back. So the way I'm going to accomplish this is I'm going to connect pin 37 to 36 and 24 to 23. They should be side by side. And that should send the CAN bus signal to the fuel pump driver module, and then we'll go check the integrity of the signal back there. So I've got the two terminals connected together. So I'm jumpering the signal and sending it to the back. Now you can see that's CAN H, and if I move the test lead over to this one, it'll be CAN L. Can't get this on here with one hand. You can see the signal shows up. Again, because the trigger's not in the right spot, it doesn't catch it. So let's plug in the ABS module and see what happens. Or ABS module, the fuel pump module. So the fuel pump module is plugged in now, and that's the CAN L signal. If I jumper this over to this terminal, there's the CAN H signal, and again the trigger's out of place so we don't catch it. So again, it's averaging about 2.6 volts with up a volt, and the other one is averaging about 2.3 volts and down a volt. Okay, so I'm going to leave the ABS module disconnected with these jumpers in here and see if we can't program that fuel pump driver now. So let's try this again. Key is still on. GMC 2009 light duty truck, Sierra. Next, fuel pump control module. It's plugged in now. Next, communicating with the device. This is where we got the error message. It's taking long enough. Isn't that special? Yeah, pre-programming instructions. Yes, I know. So, it's looking like it's going to program now. So the damn ABS module is taking out the low-speed CAN bus. Damn, that one caught me. Unplugging the fuel pump driver module, fixed the network because it opens it to the terminating resistor, which is after that. So this thing's going to need a ABS module now as well. While it was setting a fault code, what I'm going to do temporarily though is I'm just going to put 2 jumpers in there like I have. You can't leave that connector exposed though, it'll turn green and corrode in no time flat. Check the price of an ABS module. So there's the fuel pump driver module programmed. No point clearing DTC, so I'm just going to cancel now and see if this thing starts. Well, it obviously runs, has a bad exhaust leak from the left manifold, but that's a whole other issue. Fortunately, this ABS module is accessible from the back without having to take it off like the older ones were, where the module was up on top and the screws were inaccessible. So I'm going to check the availability of this module. So let's do a network scan on this truck now that it's running. I know we're going to have an ABS module, no communication, but the airbag warning light was on. I'm wondering if boosting this thing with 24 volts did in both those modules. I got the network bypassed at the ABS module right now, and that's how it's running. So let's do a code scan and see how many controllers respond this time. This takes a couple minutes, so I'll pick up when we get to the end. Actually, it's pretty quick. So we have a oxygen sensor circuit, fuel pump control circuit, module communication off the bus, lost communication with ABS, transmission undocumented, front end sensor for the airbag. Well, that would explain why the airbag warning light's on. 11, 12, 13 controllers. So as they said the other day, when it wasn't able to scan anything on the high-speed bus, there should have been about 14 controllers in this thing. And I'm picking up 13 now. Alright, so we got a record of that, so let's do a network code clear. Fortunately, GM lets you do this with the engine running, unlike other manufacturers. Controllers cleared. And
to delete an activity, like conversations with me, tap my activity below. Then find the...
My stupid phone started talking to me. I guess I must have said something that sounded like Google. Let's try a network scan again and see. I suspect we'll have that O2 sensor heater, yeah. Front end sensor code. Body codes are good. maybe have a quick look at this. Maybe the wires are ripped off that oxygen sensor. That's bank 2 sensor 2, so that'll be on the passenger side, behind the catalyst. 10 computers. Front end sensor 2. I can't remember which one it is on the right or left, but it's probably a failed sensor. We'll do a visual on that too, just because we have it up on the hoist already. We got 14 computers that time apparently. Oh, the OBD2 side of things. They treat that as a separate controller. So we need an oxygen sensor and a front end sensor and an ABS module. Oh wow. So this is likely the problem with the oxygen sensor. I can see the wires have been rubbing on the frame. And that one black wire looks like it's corroded right through. And that would be probably the O2 sensor heater circuit. Actually, it's white. Maybe I'll just splice this wire temporarily as part of the sensor. Let's have a look at the crash sensors in the front. Maybe we'll get lucky and see something visually wrong with them. There's one. And there's the other. Nothing obviously wrong. Well, this probably needs a crash sensor as well. I guess that's the secondary issue. So I fixed that bank 2 sensor 2. Bank 2 sensor 2, and now you can see the proper current on the heater circuit. And I'm sure that that's what was wrong with it. Let's see if there's any codes in it now. No. So that wire had chafed. It was a white wire that was corroded through. I just spliced it temporarily and put some loom over the harness, soldered, desealed it. So it should be okay. I'm sure this truck has other issues if we drive it long enough.